Good morning, Romeo Elementary. I'm so glad you guys could join us today. We may or may not have more classes join us, but Alan, I don't know about you, but I'm excited for today's topic.
I am as well.
Yeah. So in today's fact or fiction, we're meeting with some wastewater experts. And let me share my screen with you so that you can see what this handout today looks like that you may or may not have in front of you. So here we go. So today we're talking about a Nature of Science benchmark that talks about making predictions and defending conclusions. So today you're going to have the opportunity to make some predictions, observe some really cool things from our guest, and then come up with some explanations or some conclusions. And our claim for the day is that bacteria, think about that word, can be used to clean water. So do we think that claim is fact or fiction? All right. And as you go today, this will be your handout to record everything. I'm going to stop screen sharing because Alan, I think you have a little video clip to get us thinking before we introduce our guest.
Yes. So here we go. I wanted to kind of think about, do we think that just any old river is good enough water to drink from? So let's watch this little clip here. So we have a little creek. There's water moving around, but I'm sure there's plenty of bacteria in this water. So would that be drinkable?
So hopefully you're thinking about this. Would you drink this water? I don't know. Alan, I go camping a lot. I know you do too, right? Do you think you would drink this water?
I don't know if I would drink from it. It's a little bit scary.
Yeah, there could be lots of animals living by that water, right? And there could be all kinds of things in it.
Yeah, you don't know what's getting in it.
But we have some experts today, don't we, to talk about bacteria in the water. All right.
Yes, we do. So our two experts today is Jeff, who is the lead operator at the Cal Recharge Park. And then we also have Rachel Slocum, who is a conservation coordinator dealing with the water out there.
Great. Good morning, everyone. I'm Rachel Slocum, and this is Jeff Grieve. And Jeff is the lead operator for one of our wastewater plants here in the city of Ocala. And I'm going to show you guys a little picture of it. And so here is the facility in which Jeff oversees. And this is called the Water Reclamation Facility number 2. And we are going to talk a little bit about wastewater treatment and as a brief introduction, but primarily we're looking at what's happening in this big area right here. And that's where our bacteria are. Jeff, do you want to give like a brief overview of what happens?
Sure. Right here, right here is where all of what we consider the dirty water coming into the plant is. Right here is a low to zero oxygen zone. And this is where certain microbiology works for nutrient removal, say removing nitrogen from the water. And right here on these zones, this is a high oxygen zone. The bugs want to eat and they want to breathe. So this is where we make the bugs nice and happy right here. Back here, we kind of give them, I guess, maybe stress them out a little bit because we want them to remove the nitrogen. Once the nitrogen is removed, then it comes through these tanks right here and settles out to the bottom. And then we can pump it to these tanks or back to the beginning of the plant and kind of like a population control for us.
So we'll like zoom in a little bit on our little bugs here. So one of the most exciting things is these microorganisms, which means we have to use a microscope to see them because they're very small. So we have to use something that can magnify them so that we can see them really well. So if they were macroorganisms, we could see them with our naked eye, but they are micro, so we have to use a microscope to see them. So we have a microscope set up for us today, and we're going to try to see some of these bugs that we're going to potentially find in the wastewater process. But one of the interesting questions, I guess, like I wonder where these like bugs come from. So let's just think a second. So this is a wastewater plant. So this is everything that's leaving your house. So this is everything that's going down your shower, going down your washing machine drain, going down your dishwasher, your sink in your kitchen, and your toilets. So all of that water is coming to this plant. So these microorganisms, we're not growing them. We're not shipping them in. We're shipping them in from your houses. So these are the microorganisms that are coming out of you and me when we go to the bathroom. So it's pretty cool. It's pretty gross. It's pretty great. And so we're gonna look at some of the ones that we could potentially find. So we're gonna take a moment and go to our first column on our sheet that you guys have. And so we're gonna observe, and we're gonna have the potential to observe some of these microorganisms. And so we have the option to see maybe some stalked ciliates, which is what this first one here is, some amoebas, some carnivorous free-swimming ciliates, and maybe a seed shrimp, a crawling ciliates, or rotifers, or even a water bear or a tardigrade, or some nematodes. And so we're going to go ahead and look at that first column on your sheet, and we're going to make, let's see, let me pull it up. We're going to make some predictions on what we think we might see. So let's all take a look at our chart here and maybe write down which species you think we might see in our slide that we've pulled up. And so we went in that big brown area on that picture we just showed you. Our operators went and grabbed a little bit of sample, a little bit of our bugs from there, and we put it on a slide on our microscope. And we are going to try to find some of these critters, some of these bugs, some of these microorganisms. So we'll take a couple minutes if you guys want to write down what you think you might see. So if you think you're going to see, maybe we're going to see a stalked ciliate and a rotifer and maybe a seed shrimp, you can write those three down. So we're trying to figure out what we may see in the water. So are we all writing stuff down, making some predictions? And so these little bugs are the ones that are doing all of that nutrient reduction, or specifically they're indicators for other bugs, but they're doing nutrient reduction, and they're making sure that when that wastewater comes through the plant, it's pretty dirty, right? It's kind of gross. They're going to make sure that they clean that water up really good, so that when we're done with it, we can send it to the wetland park and it'll be cleaned even more. But we don't want to send gross, dirty water out into the public. And so these bugs are working really hard to make sure that our water is super clean and it's not going to harm the environment. So I think we're writing some stuff down. We've got some movement happening. So if you think, maybe we're going to have an amoeba and a crawling ciliate and maybe a nematode, you can write those down and kind of take it all in, make some notes. I'll give you guys just a couple more minutes or a couple more seconds to kind of work out what we may have on our slide. Jeff is checking our microscope over here. I'm going to move the camera down a little bit so you guys can see our microscope setup, and there's a slide on there. Should be pretty good. So all right, so if you are all done making your predictions on which critters you think you're going to see, if you could put your hand up so I can get an idea. If you're all good. Oh, I see some hands. All right, we got some predictions made about which critters we're going to see. This is great. All right, perfect. So are you guys ready to see what's on our microscope slide? Yeah, let's do it. All right. Boom. Okay, so we've got a little guy moving right here in the corner. Look at him. Jeff, what is that?
That looks like a crawling ciliate.
We have a crawling ciliate. So if we want to put down observations, we can put down a crawling ciliate. Jeff's going to try to get him in focus here a second, but he's behind all this muck, but he's moving. Oh, there he is. We got a little crawling ciliate that we pulled out of there. So make sure to write crawling ciliate down in our observations. Oh, look at him. Look how cute he is. Oh, is there something else moving up here? All right, look at this big guy up in the top. Look at him. All right, Jeff, what do we got here?
That looks like a rotifer.
Do you think it's a rotifer, or do we think it's a free swimming ciliate?
I think maybe a free swimmer. He's a big free swimmer.
He's a big free swimmer. And so if you wrote free swimming ciliate down, you can put that in our, like, maybe make a little tick, but put that in our observation. So far we've seen a crawling ciliate and a free swimming ciliate. Let's see what else we can find. We're moving around. We're taking in the sights of our slide here. It's kind of creepy, kind of gross, but pretty cool. Oh, what's happening here? Whoa! Oh my goodness! Look at these guys.
That's a water bear.
There's a tardigrade, and he's huge. So if you wrote down a water bear, look at his little feet. You can put that down so you can see they're called water bears because look at their little feet. Look at them. They're great. So tardigrades are often studied, and they've gone to space because they've been like, oh, look at his little face. They've been frozen in glaciers for hundreds of years and thawed out, and they've just been like living their lives afterwards. He is like stuck in here.
He's having a good old time.
He's having a good old time. And if it was a female, and sometimes the females will have eggs in them, and you can see all the eggs in them too. So pretty cool water bear that we just found.
I've never seen him so active before.
Just moving around, having a great time. Just the joys of microorganisms here. Some water bears are actually large enough that you can see them with the naked eye. So of course, like, there are many different species of water bears. This is one specific one. I couldn't tell you which one it is exactly, but Jeff's going to try to focus in on his little face. He's so big. He's having a great time. Okay, so far we've seen a free swimming ciliate, a crawling ciliate, and now we saw a water bear, which is very exciting. We don't get to see water bears super often. We keep our bugs, we farm our bugs for about a couple of weeks, up to 14-ish days, and you usually don't see water bears until the sludge is a little bit older, or the bugs are a little bit older. And so we really lucked out finding this water bear today. So awesome find. If you guys have seen, there's like in the Ant-Man movies, when they go subatomic particle size, there's a big water bear in there. So let's see if we can't find anyone else. Oh, who's that back there? Oh, we got a little guy right here. Looks like we might have another free swimmer, Jeff. Yeah. Another free swimmer hanging out right here. So we've got 2 free swimmers so far. And I think if we go up a little bit more, yeah. Oh, what's this? Oh, that's just
debris.
Just some debris in there.
Oh, here's something.
All right, let's see what we can find. Oh, maybe up a little bit more. I think there's somebody moving around up here. Yeah. Oh, wow!
Yeah, they're hard to keep track
of.
of.
Free swimmer just rolled into the screen. That was pretty exciting. So I think we've seen 3 free swimmers so far. That's that same one moving around. Oh, what was that moving over here? Do you see him? Ooh,
there he is.
Another little crawling ciliate. He's gone.
Yeah, it's hard to keep up with. He's hard to keep up.
So it looks like we have a water bear, a free swimming ciliate, and a crawling ciliate. Often we'll find rotifers and stock ciliates, but maybe not in today's poll sample. Thank you, Jeff. So we'll try to find stuff for a couple more seconds, and then we can. Looks like that was a hair.
It could be.
It might be a hair.
They're so telling it's possible.
So you have to think that everything that gets flushed down the toilet or goes down the drain ends up in our wastewater treatment, and they're just pulling this from this area of the plant that has all of that influent or everything that's coming in from from what's going down your drains. It's mixing with all of our bugs. So we get a little bit of what's coming in, but also our microorganisms that are doing that treatment. And so like Jeff said, there's another little crawling ciliate like moving around.
Yeah, it's hard to keep up with.
And he's running off the screen. So so yeah, we have all these like microorganisms that are doing this treatment. And Jeff said a little bit about reducing nitrogen, and nitrogen is really what we're after in effective or good wastewater treatment. Oh, there's a big free swimmer there. Look at him, it's huge. Blah. He's kind of gross looking, right? He looks like a leech. So we're looking for nutrient reduction, and that happens with these like little microorganisms. And they, Jeff said, on one side of the tank, we have no like readily available oxygen. And on the other side of the tank, there's lots of oxygen. So when they move to this this low oxygen side of the tank, they're kind of suffocating. And so what they're doing is they're stressing out these bugs. And so they have this nitrogen and nitrate molecule, and it has oxygen attached to it. So these little microorganisms, because they're so small, can rip that oxygen off of that molecule to be able to breathe. And the nitrogen goes into the environment. So that's how we help clean the water and make sure it's safe to be sent to the wetland park or sent to potentially your school field. School grass might be irrigated using or watered using our water from this plant too. So lots of really cool things. So let's go check out our last kind of column on our form, which is explain. So we did see some biodiversity like in our let's see, new share, stop share, in our slides. So that's good. So we saw lots of free swimmers, we saw lots of crawling ciliates, and we saw a water bear. So Jeff, do you want to talk a little bit about, as an operator, like what you're looking for when you're looking at these different bugs, so we can explain how that shows good wastewater treatment?
Well, the different species, based on what species we see, is going to tell us the age of the sludge. You don't want the age of the sludge to be too young or too old, because at the end of the day, if you have a good mix of different age of bugs, it improves the clarity of the water. So the water that might go out of this plant for irrigation, we want to make sure that the water is as clear as possible, because if it's too young, if there's an overabundance of the water bears or the crawling or the free swimmers, then we don't achieve the clarity of the water that we're after.
Great. And so we're looking for lots of different kinds of species, right? So like if you only found water bears, that would potentially mean that our sludge isn't very healthy and we're not getting good treatment. Or if we only found, there are some bugs that we don't want to find. What are some of the bugs that we don't want to find, Jeff?
Actually, go, if you have the slide.
Yeah, I'll pull up the slide really quick.
Down at the bottom right, nematodes.
These guys right here.
Those will actually starve out the other microorganisms, because they will take all the nutrients that the other ones need to survive, and they don't give us as good. You still have some treatment, but just not as good as the other species. So yeah, so there's some bugs that we want to have, some bugs that we don't want to have, and all of them kind of impact the way that we treat here. And if you think, like, we're going off of everything that's coming in. So we're kind of subject to whatever people are deciding to flush that day. And since we have these bugs and they have to do this treatment, if somebody flushes something that kills the bugs or hurts the bugs, then treatment's going to be messed up. And since we keep these critters alive for a couple of weeks, it's not like we can fix the problem the next day. It takes a long time. It could take months for the wastewater process to get back into good process for us to do that. So let's see. I think let's make sure that we answered our questions.
And Rachel, they can do those after, because I think they're
Perfect.
definitely going to have some questions for you.
Yeah, and I think Jeff and I are both ready for some questions. If you guys want to start directing those our way, we love talking about poo.
We love questions.
Perfect. Yeah, so Ms. Stewart, if you would like to write some questions in chat, I will ask them to Jeff and Rachel. So Jeff, I'll give you about a minute or so to come up with their questions.
And Alan, I had a thought, since we only have one class joining us, if Miss Stewart has a microphone and they want to unmute and call students up to ask them, I think
That
that'd be
sounds
a
great.
great.
That sounds like a wonderful idea. All right, if you don't have a microphone, that's okay. You can just write in chat for us.
Great. I'm excited to hear what they're going to say, Jeff.
Mhm.
We love questions.
All right, so our first question is, why are all those bacteria in the water?
Jeff, you want to take this or you want me to?
Go ahead.
Okay, so I think we talked a little bit about this when we started, but you know, bacteria are everywhere. Like we're covered in bacteria right now, and they are actually helping us digest our food. So in the wastewater process, we have to take everything that you send, and you're going to be flushing some bacteria when you go to the bathroom. And so we utilize those bacteria, and there's bacteria like in your shower water and in your clothing water. There's bacteria in all of that. And it's not all bad. So like not all bacteria is bad. Most bacteria is really beneficial. And the bacteria that we're farming here at the wastewater plant are beneficial bacteria. But we get them primarily from your gut, from what you flush down the toilet. And it's great.
So you're saying there's
So
bacteria
thank you for
inside
your
of me
contributions.
and on my skin?
And on your skin. Yep.
Hair, everything.
Hair, everything. Yep. So it's pretty fascinating.
That is pretty fascinating. Let's see. Do you have any? All right. Are there other kinds of bacteria you see?
Yeah, so we can go back to, I must have closed that window really quick. So we can go back to that slide really quick. All of the ones that were, oops. Yeah, it's on this. All of the ones that are on this slide are ones that we often see. We don't want to see the nematodes, but we can see some of these other ones. And if the sludge is a little bit younger, we're more likely to see maybe these stalk ciliates, right, Jeff? And some of these rotifers. And then the older sludge, we got to see what we saw today. So these like crawling ciliates, a water bear, and that free swimming ciliate. So all of those are things that you can see. Jeff, can we see anything else?
There have been times where we have seen microorganisms that we ourselves don't recognize, but it's unrelated to wastewater treatment. But there is possible that you might see something else apart from like the normal things that we were used to seeing. But again, it's one of those things where we've just run across it and it's not a part of the process.
Anytime I've ever seen the word amoeba, I've always seen as like brain-eaten amoeba. So they're good kinds of amoebas?
Yeah, so there's good and bad of everything, and not all amoebas are bad, especially in Florida. I would say that we're kind of exposed to them being considered like brain-eating amoebas, but those are very specific to our public waterways or our lakes that we have here because of the temperature in which the water can get. And so it like spawns this very specific kind of amoeba, but not all amoebas are brain eating. Some of them are just doing their thing, just eating some nutrients and potentially other microorganisms.
But it would be a problem if I looked on the microscope slide and all I saw were amoebas. That'd be a big problem.
That definitely calms my nerves a little bit.
Yeah.
We have a few more minutes. Are you able to move your camera around and give us a little bit of a lab tour possibly?
Oh yeah, we could do that.
I can.
Let me stop sharing here for a second. And so we have actually Ben Moose just walked in the background, and he's a pretty important guy. Ben, come into the camera frame. Great. So keep coming.
I'm backing up.
Great.
There you go.
So Ben is our compliance monitoring manager, and that's a really fancy title. But so not only do we manage like all of the waste that residents are sending into the city, but we also manage all of our industries and our restaurants. So every restaurant can send their wastewater to this plant. And so Ben and his team kind of make sure that they're not putting bad things down the drain, because of course they're producing way more waste than a household is. And then we also do things like signature brands. And like, so seasonally, their water is different colors. And so sometimes it's blue or green or purple or red, because if they're doing egg dyeing kits or sprinkles or something, and they're those specific colors, like their wastewater are those colors. And so we regulate those industries. And so Ben does a lot of that. But let me grab up this camera and I can, let's see. Okay, here we go. So he's going to move our white balls here. So this is our operators lab. Jeff, do you want to kind of talk about like the labs that your guides do?
Sure. So like to find out.
There we go.
How's that work?
It's good. It's good.
Okay. To find out, we have to maintain a certain amount of bug population. So that's where this device is like a vacuum filter, and we'll put some of the sample that we put on the microscope slide, we'll put through this this filter, and we bake it in an oven, and then we weigh it, and then the ending weight will tell us the population. We don't want the population to get too high or too low. So we have different ovens and furnaces that probably the camera can't catch, but it's on this side. But with this various equipment, we'll also measure what the chlorine content of the water is in. Can you see that?
I'm a really good camera operator.
So in those ovens, we'll find out like the bug population. This is called a DR300. We'll measure the chlorine content of the water. We use the chlorine for disinfection. This is a pH meter, so we have to monitor. We don't want the pH too high or too low. So this will measure the pH in the water, and this will measure this. Let me see if I can pull it up. This will measure the turbidity. Basically, if it tells us how clear the water is. So that's pretty much our three parameters: pH, chlorine, and turbidity.
How often did you do the labs, Jeff?
Chlorine, turbidity, and pH are continuously monitored, but once a day we will compare the outside meters to these inside meters for accuracy.
So yeah, so that's day in the life. And we have operators here at this facility 16 hours a day. So they do 2 shifts. So we have a day shift and an afternoon shift.
And overnight we have an on-call. We have a SCADA program that automatically calls people out if there's a problem.
Right, because people don't stop showering even then when we're not here. So
the plant never turns off.
Rachel and Jeff, thank you so much for giving us this sneak peek into your lab and showing us all of those microorganisms under the microscope. It's fascinating to see how we're treating that wastewater to make it healthy enough to go back into the environment. So Romeo Elementary, also thank you for joining us early on this Tuesday morning. We'll be back on at 1 p.m. and thank you.
Yeah, I think she snuck one more question in.
Oh.
And she snuck in, is river water safe?
So would we see some of those microorganisms in the river water?
Yeah, it's possible.
Mm-hmm. Yeah, you definitely would. And the thing with any sort of water is like, unless you know it's safe to drink, just don't drink it. And you know, like our drinking water, municipal water is super safe to drink because we test it every 2 hours to make sure that it's safe to drink. But river water, it's probably not tested ever to make sure it's safe to drink. And you don't know if a deer went to the bathroom and he was sick and now you're drinking it. So there's a lot of things you have to think about, or pollution that gets in there as well from just residents. So it would have to have a lot of testing, but you'd probably have to do some sort of treatment to it before you could drink it.
So those microorganisms are helping to remove some of the bad stuff in our wastewater, but we probably don't want to be drinking all of those microorganisms, right? So at some point you get rid of them, right?
Yeah, we filter them out of the water, we settle them out, and then we filter any residual ones out, and then we disinfect. We use chlorine, like bleach, to make sure if there's any bugs left in the water, they're not alive anymore.
All right, good to clarify. All right, thank you everyone, and bye-bye.
Bye.